Hi folks, welcome back to Physics with Captain Rod. We're going to discuss number 27 in your homework, which is, virtually the same problem as 26, but you're going to attack it with a different method. All right, so the first directions. All right, draw free body diagrams of both masses and the pulley. So let's discuss this animal right here. When you draw your free body, it should have two forces on it. Right, a tension and a gravitational force. And that's it. And you should also tell which one is going to be larger in the problem too, by the way. And I'm not going to tell you which one, I'll let you think about that, but I will mention this. Think about the acceleration direction. That'll tell you which one is larger. Okay. Next, let's talk about this one. That free body should have also two force vectors on it, a gravitational force and a tension. Okay. And it's important to realize the tensions are not going to be the same in this problem. Whatever the tension is over here, I'm going to call it T1 here for this video, is not the same as over here. So I'm going to call this one T2. And that's because of the inertia of the pulley. Right. In a lot of the previous problems we looked at, the pulley was very light and it was not a big deal or a big part of the problem. But in this problem, the pulley is a reasonable part of the problem. So if we kind of list our unknowns here, tension 1 is not directly known. Tension 2, also not directly known. The acceleration of these masses, also not known. And I guess one could argue the angular acceleration of the pulley is not known. All right, but I might as well talk about this right now. These two are directly linked by the acceleration is equal to r times alpha, the angular acceleration. So for all practical purposes, this problem has three unknowns. The two tensions and the acceleration. All right. Now let me chat about the free body of the pulley. You should have 4 forces in that free body for that free body to be correct. But I don't want to tell you what they are. I'm going to let you decide on that. But I will tell you that 2 of them should have a line of action on that line. 2 of them. Right. Now, when you write your Newton's second law equations for your free bodies, I'm sure that's going to be the next part of this. Yeah, find the angular acceleration and find the tension in each rope. Okay. When you write your Newton's second law equations for this, keep in mind that that thing is accelerating down. So when you write that equation for that free body, you want to do so with down positive. And the right-hand side of the equation should be ma. If you want to write it 12 times a, because that's what this mass is, that's fine. Okay. This mass here is accelerating up. So when you write your Newton's second law equation for that mass, you're going to want to do so with up positive. Okay. Now, when you get to that point, you should be looking at 2 equations that have basically 3 unknowns. The 2 unknown tensions and the unknown acceleration. So you have to write another equation. That's going to come from your free body of the pulley, and it's going to be a torque equation. So for the pulley, you're going to want to write out the sum of all torques equals I alpha for the pulley. And the pulley is rotating counterclockwise. I would just call counterclockwise positive. So when you write that torque equation, you should have a force applied basically here, creating counterclockwise torque. You should have a force applied here, creating clockwise torque on the pulley. And the 2 forces that go through this line of action here should not create any torque at all. Right? So you should end up with a third equation out of this. And from there on out, it's an algebra problem, right? It's kind of like 3 equations, 3 unknowns, but it's not too bad. So hopefully that'll get you through this problem. I hope that this helps. Have a great day.